In this video, we are going to discuss about the programmable logic devices, especially how the PROM can be used to design any given switching function. So first, we are going to discuss about programmable read-only memory. So generally, the programmable read-only memory denoted as two power n into m. So 2 power n into m represented as the PROM consists of n to 2 power n decoder into 2 power n decoder and m number of OR gates, right? So any PROM consists of n to 2 power n decoder and m number of OR gates. First, to design any given switching function by using PROM, first you have to identify how many number of inputs, how many number of outputs. Let number of inputs as n, number of outputs of given expression, given Boolean expression or given combinational circuit. Right? You have to identify number of inputs and number of outputs. Number of inputs are n, number of outputs are m. If you are able to identify number of inputs and number of outputs for given combinational circuit or given logic, so you can identify which size of PROM is preferable to design given circuit, right? So n known, m known, the size of a PROM represented as 2 power n by m, right? Now consider one simple example, that is off adder using PROM, and we are familiar about off adder. So off adder consists of how many number of inputs? Number of inputs are 2. Let a comma b, right? Outputs, off adder providing the two outputs. One is the sum, another one is the carry, right? So here what is the n value? N value is 2. What is the m value? M value is 2. That is number of inputs, number of outputs. So to design this given combination circuit, which size of a PROM is preferable? The size of a PROM is denoted as 2 power n into m. Right. Here what is the n value? 2. 2 power 2 into what is the m value? 2. Right. N value, m value you have to substitute. Here 2 power 2 represent which type of decoder is required? N to 2 power n decoder. N to 2 power n decoder. So here n value is 2. So 2 to 4 decoder. So PROM which consists of 2 to 4 decoder and m number of OR gates. Here m value is 2. So 2 OR gates. Such type of PROM is you have to select. Then you have to write the truth table which gives the relation between input and output. So let inputs are a, b, outputs are sum and carry. So we know the truth table of off adder. Just we have written the truth table of a off adder, right? So for 0 0 sum 0 carry 0, for 0 1 sum 1 carry 0, for 1 0 sum 1 carry 0, for 1 1 sum 0 carry 1. Then we are writing the CSOP expression for every output. CSOP expression, that is sum of minterms, right? What are the minterms here? A bar, b bar, that is 0, 1, 2, 3. These are the minterms, right? Sum equal to summation of minterms of 1 and 2, right? we have written the CS swap expression for sum and carry. So where carry is 1 for min-term 3. So min-term 3 included, right? After writing the truth table, you have to write the CS swap expression for sum and carry. No need to go for the minimization. Why? Because PROM consists of 2 to 4 decoder. So what is the purpose of a 2 to 4 decoder? What is the structure of a 2 to 4 decoder? So 2 to 4 decoder purpose is to produce all possible minterms for given inputs. Here 2 to 4, this is the block diagram of a decoder. So decoder having how many inputs? 2 inputs, A and B. How many outputs? 4 outputs. Let Y0, Y1, Y0, Y1, Y2, Y3. So I think all of you know about the decoder. Decoder consists of how many AND gates? 4 AND gates in case of 2 to 4 decoder. So every AND gate producing the, so let this is A bar, B bar, right? So for this AND gate, A bar, B bar given. For this AND gate, A bar, B given. Let A, B. I think all are you familiar about the decoder. So for this A, B bar, for this one A, B you have to give. So every AND gate producing the all possible combination of minterms for inputs. Here inputs are A, B. So A bar, B bar is available. A bar, B is available. A, B bar is available. Then A, B available. All minterms are available. So any output, any boolean output can be expressed in terms of sum of minterms. If minterms are available, what you have to do? Just you have to provide the summation. That means for providing the summation, we have to use the 1 OR gate. For sum, which minterms you have to connect? 1 and 2. For carry, which minterm you have to connect? A, B you have to connect, right? So no need to minimize, no need to use the K-map for simplification, right? Here we make use of PROM to design the given combinational circuit, right? So this is the CS swap. These are the CS swap expressions for sum and carry. So this is the structure of a PROM. So observe the PROM structure. It consists of 2 to 4 decoder. Why? Because here n value, that is for half adder, number of inputs are 2. Number of outputs are, number of inputs are 2, number of outputs are 2. So number of inputs are denoted as n, number of outputs denoted as m. So which type of decoder? N to 2 power n decoder. So 2 to 4 decoder. How many number of OR gates? 2 OR gates. So this is the structure. It consists of 2 to 4 decoder and how many OR gates? 2 OR gates. Every OR gate consists of 2 power n number of electrical fuses. Here how many outputs are there? 4 outputs are there. So 4 electrical fuses are present for OR gate. This fuse for Y0, this fuse connection for Y1, Y2, Y3. Similarly, these OR gate is also consists of electrical fuses for every output of the decoder, right? So these OR gate consists of 4 electrical fuses. These OR gate consists of 4 electrical fuses, right? Total 8 electrical fuses are present. PROM is denoted as 2 power n into m, right? Here what is the n value? N value is 2, right? So 2 to 2 power 2 into m. What is the m value? Number of OR gates, that is 2, right? So 4 into 2 means how many electrical fuses are there? 8 electrical fuses are there. Or indirectly, for every given combination, for every given input combination, how many bits are available? Here may be 0, 0, 0, 1, 1, 0, 1, 1 based on these fuse connections. So total how many bits we can store in this PROM? 8 bits we can store. That means truth table of half adder, if I observe, sum consists of 4 bits, carry consists of 4 bits. So those 4 bits we can read from this configuration, right? So now what is the sum expression? Sum is equal to sum of minterms of, what are the minterms? 1 and 2. What is the carry expression? Sum of minterms of only 3. So which fuses you have to connect? This fuse for y0, this fuse for y1, this fuse for y2, this fuse for y3. So which fuses we have to connect? We require the a bar, b bar, and we require the a bar, b. Here what are the products we are having? A bar, b bar is available. A bar, b available. A b bar, then a b available, right? Sum is nothing but a bar b plus a b bar, right? So which products we require? This product. So corresponding fuse you have to make a connection. Then this one is required. A b bar is required. So this, right? So this is about how the fuse connection to get the sum. Similarly, carry. So what is the carry expression? Only AB. Right? How can you get the AB? Which fuse you have to connect? All fuses are there, but you have to make a connection according to your required output, right? So which product is enough? AB is enough to get the carry. Only that fuse is connected. Remaining fuses are get opened. Right? This is the way to configuration. Right? So very similar. Another alternative representation of the structure of a PROM is just 2 to 4 decoder and m number of OR gates. Just to draw one vertical line which joins all outputs of a decoder. So these are the lines for outputs y0, y1, y2 and y3. And this is the one vertical line. Every intersection, right? This is one electrical fuse. This is one electrical fuse. This is one electrical fuse, right? Every joining of horizontal and vertical line representing the electrical fuses. So how many intersections? 4 intersections. That's why 4 electrical fuses are present. Here also 4 electrical fuses are present. So which fuses you require to get the output, that is sum, at that intersection you have to put just a cross mark. These cross marks you have to put. We require the y1 and y2, minterm 1 and minterm 2. So similarly carry. So for carry which one is required? 3 is required. So this is the way to design any combinational circuit by using PROM. Right? Let's consider one more example, that is off subtractor. Off subtractor. So here also, what is the n, what is the m? That means number of inputs, number of outputs. So n equal to, in off subtractor also how many inputs we are having? 2 inputs. How many outputs? Let outputs are m. So how many outputs are there? 2. So to design this combinational circuit, whatever it may be output, later we will think about the outputs. First we have to identify the number of inputs and number of outputs. N value, m value required. Based on that we can find the size of a PROM. What is the size of a PROM? N2, 2 power n decoder should be present. And how many number of OR gates? M number of OR gates required, right? So in this case, that is 2 to 4 decoder. And how many OR gates? 2 OR gates. Once you know the n and m value, we can select appropriate PROM to design our combinational circuit. Here what is the combinational circuit? Off subtractor. We know the truth table of a subtractor, and the off subtractor having the a and b as inputs, a, b inputs. How many outputs? Borrow and difference. We know the truth table. For borrow, what is the minterm? 1. For difference, what are the minterms? 1 and 2. So we are writing the CSOP expression for borrow and difference, right? So you have to select PROM structure. So this PROM structure also requires 2 to 4 decoder and 2 OR gates. Why? Because here n value 2, m value 2. So same structure is enough to design the off subtractor also. But fuse connections are different. So to get the borrow, what is the expression for borrow? That is a bar b. What is the expression for difference? A bar b plus a b bar, right? What are the minterms are available? A bar, b bar, A bar B, A B bar, then A B. So these fuse connections. To get the A bar B, these electrical fuse connection you have to make a connection. Then next, to get the difference, A bar B, A B bar, you have to make a connection. So another alternative way to representing this, instead of drawing this electrical fuses, simply we can draw the one vertical line which join the all outputs of a decoder. So every crossing representing the one electrical fuse. Just which fuse is required, just to put a cross mark at that is fuse. Right here, Y1 fuse you have to make a connection to get the A bar B. So that's why Y1 just to put a tick mark. Then to get the difference, Y1 and Y2. Right. So take one more example, full adder. So in case of full adder, what is the n value? So we know that full adder receive 3 inputs, A, B, carry, in. These are the inputs. So n value equal to 3. What are the outputs? Sum and carry out. Right. So what is the m value? M equal to 2. So we know the n value, m value. So which type of PROM? 2 power n into m. Right. So here what is the n value? 2 power 3 into what is the m value? 2. Right. So these PROM consists of which type of decoder? Decoder which is having 2 power 3 number of outputs, that is 3 to 8. 2 power 3 is nothing but, so 3 to 8 decoder. How many OR gates? 2 OR gates. That structure you have to select, right? After selecting that structure, you have to write the truth table of full adder and get the output expressions for sum and carry out in the form of CSOP, right? So we know that sum equal to, I think all of you familiar about the full adder, right? I think all of you familiar about truth table of a full adder. So what is the truth table of a full adder? A, B, C, I, it is C out and sum. I think all of you familiar, right? So again I am repeating 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, sorry, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, right? This is the truth table for which combination sum is equal to 1, that is minterm 1, minterm 2, minterm 4, minterm 7, 1, 2, 4, 7, carry 3, 6, 5, 7, so 3, 5, 6, 7. So after writing the CSOP expressions, just you have to select this type of PROM. This type of PROM is required. So you have to draw the structure of a PROM. 3 to 8 decoder, 3 inputs, A, B, C in, 8 outputs, all 8 minterms from A bar, B bar, C in bar to A, B, C in, right? So for every output there is a fuse connection at input of a OR gate. So OR gate consists of 8 number of electrical fuses. These OR gate is also having the 8 number of electrical fuses. To get the sum, which fuses you have to make a connection? So Y1, Y2, Y4, Y7. These fuses you have to make a connection. That is Y1. Truth table CSOP explain you out. Y1, Y2, Y4, Y7. Those fuses you have to make a connection. Remaining fuses get opened, right? So to get this carry out, 3, 5, 6, 7. These fuses you have to make a connection. Remaining fuses are open. So this is the one way to represent Y1, Y2, Y4, Y7, Y3, Y5, Y6, Y7. At those places, just you have to put a cross mark to representing which fuses are connecting in PROM, right? By using same structure, you can design the full subtractor also. Full subtractor also having n value 3, m value 2. So the same structure you have to use. Just according to the truth table and the CSOP expression of a bar out and the difference, you have to make a few connections to get the logic of full subtractor, right? So we're not designing dedicated circuit for full adder, full subtractor or any combinational circuit. By using PROM, we are realizing given combinational circuit, right? Take one more example. So for example, this is the some combinational circuit given having the 4 outputs like F1, F2, F3, F4. 4 outputs are given. How many inputs are there? Every output depends on how many inputs? A0 to A2. So how many outputs are present? Sorry, how many inputs are present? 3 inputs are present. So here, how many inputs? 3 inputs. How many outputs? 4 outputs. Inputs are A2, A1, A0. Outputs are F1, F2, F3, F4. So the directly in the given question, given logic, CSOP expressions of every output is given. Just only one thing, which type of PROM is preferable? We have to select to design the circuit, right? Here what is the n value? N value equal to 3, m value equal to 4. So which type of PROM? PROM is denoted as 2 power n into m, right? Here what is the n value? 2 power 3. What is the m value? 4. So to draw the structure, which type of decoder you have to consider? 3 to, that is n2 2 power 3 decoder, right? That means 3 to 8 decoder. And how many OR gates? M number of OR gates. Here what is the m value? 4. So first you have to draw the logic. This one. Which type of decoder? 3 to 8 decoder. How many OR gates? How many outputs are in given logic? 4 outputs are there. So 4 outputs, 4 OR gates. Just you have to make a few connections to get the F1, F2, F3, F4. Directly CSOP expressions are given 5, 6, 7. Just you have to make a few connection at 5, 6, 7. So similarly F2, similarly F3, F4. Just to make a fuse connection according to given, right? Where F2 equal to Y1, Y1, Y2, Y3, Y4. So next Y3 equal, F3 equal to Y0, Y3, Y4, Y7. Right? This is about how to design a given combinational circuit. So one more example taken. 3-bit circuit which accept 3-bit number and generate output binary number equal to square of the input number. So input consists of how many bits? 3 bits. So what is the n value? N equal to 3. By using 3 bits, how many combinations we can construct? 0, 0, 0, 0, 0, 1 and so on. 1, 1, 1. This is the minimum value, minimum input value 0. This is the maximum input value 7, right? So what is the circuit to be designed? Output binary number equal to square of the input, right? So input is 0, input is 0, 0 square 0, input is 1, 1 square 1. If input is 2, 2 square 4 and so on. If input is 7, 7 square 49, right? So at output side, the number value minimum is 0, maximum is 49. To representing the 49, how many binary bits are required? So weight 32, 16, 8, 4, 2, 1, right? Which weights are required? 32 required, 16 required, so becomes 48. 8 not required, 4 not required, 2 not required, 1 required. So therefore, how many binary bits required to representing the output? right? 6 bits are required. So we have to express output in terms of binary. Here what is the output? Square of the input, right? Input consists of 3 bits. Highest combination is 3 ones, so that is 7. 7 square is nothing but 49 is the output to be. So to representing the 49, how many bits are required? 6 bits are required. So every input combination 0 0 0. How can you express? 0 square 0 square 0, 1 square 1, 2 square 4, 3 square 9, 16, 25, 36, 7 square 49, just the square of a input. For this 0, we are writing the binary equivalent, all zeros. 1, 4, right? Only 4, remaining all are 0. 9, what are the weights are required? 8 required, 1 required, remaining all are 0. So these are the weights: 32, 16, 8, 4, 2, 1. We have to express our output in the form of binary by using these weights. 16 weight is required, remaining all are not required. 25, to get 25, 16, 8, 1, 36, 32, 4, 49, right? So after writing the truth table, we have to write the CSOP expression for every output. What is the CSOP expression? B5. B5 depends on given inputs. A to A1 A0 equal to sum of minterms of, what are the minterm combination? 6 and 7. 6 and, right. So similarly, what is the B4? B4 equal to sum of minterms of B4. 4, 5, 7. 4, 5, 7. Then B3 equal to sum of minterms of 3, 5. Next 2, 6. B2 equal to 2, 6. B1 completely 0. We're not having any logic one here, completely 0. Then B0 equal to sum of minterms of which combinations? 1, 3, 5, 7. 1, 3, 5, 7. After writing the CSOP expressions, just which type of PROM you have to select? N equal to 3, M equal to 6. So PROM denoted as 2 power n, denoted as 2 power n into m, right? Here m value is 3, m value is 6. So 2 power 3 into 6. So which type of decoder? 3 to 8 decoder. How many number of OR gates? 6 OR gates. So you have to draw the structure. Then according to CSOP expression, just you have to put a cross mark, right? This is about how to design Boolean expressions or combinational circuit by using a PROM. Sometimes in examination, just design. For example, here, let one example. Only one output given, f of a, b, c, d equal to sum of minterms of 1, 2, 4, 5, 7, 9, like that, right? So here how many outputs? How many inputs we are having? 4 inputs. So what is the n value? N equal to 4. How many outputs are there? Only one output is given. So what is the m value? M equal to 1. So design this Boolean equation switching function by using PROM means just whatever it may be given question. You have to identify number of inputs and number of outputs. So only one output is given. So m equal to 1. How many inputs are there? 4 inputs are there. M value you have to identify. According to that, you have to select PROM. So PROM is denoted as 2 power n into m. N value is 4, m value is 1. So which type of decoder you have to draw? 4 to 2 power 4. That means 4 to 16 decoder you have to draw. Just a block diagram. Just you have to draw the block diagram like this. Block diagram of 4 to 16 decoder you have to draw. 4 inputs you have to connect. How many outputs are there? Y0, Y1, Y2, and so on up to Y15, right? You have to draw the one block diagram. How many OR gates? Only one OR gate. Just you have to draw the one OR gate, and that OR gate having the one vertical line which join the all 16 outputs of 4 to 16 decoder. Which minterms are given? These minterms are given. For example, 1, 2, 4, 5, 7. Just you have to put a cross mark at corresponding positions. This is the way to design any given Boolean function, any combinational circuit by using PROM.